Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching PU2 Brahmastra series. Today is day 26 and I am going to discuss a very important chapter, wave optics. Okay, I know many students are not aware, not understand this chapter properly, so let's break it down and understand this chapter completely through today's question answers. We will discuss 30 questions, very important questions from this chapter, and after going through this many questions, there should not be any doubt, any questions left in your mind, right? But let's look into the week's plan. This week I have already completed ray optics and optical instrument. Many students were saying, sir, is this sufficient? Yes, at least this is sufficient for you to cover this chapter. Some mathematical numerical questions obviously might come. I cannot predict the numerical questions, but pattern questions might come. Okay, other than that, for theory portion, that is sufficient. Okay, numerical questions obviously they can ask new type of numerical questions, but if you solve these two numerical questions along with numerical questions from NCERT for that chapter, that should be sufficient. Now biology, biotechnology is done. Okay, chemistry solutions are done. I hope you have watched all these videos. Today I am doing wave optics. Tomorrow will be maths and biology together, so application of integrals will be there for maths, and for biology, microbes in human welfare. Then Sunday will be maths, application of derivatives. So these are all the upcoming topics from this PU2 series. Now if you are currently studying in PU2, I guess you are, then you must be wondering how can I score better in our upcoming PU2 exam, right? So we are presenting a special test series called PU2 Success Blueprint Test Series, and it is going to be starting from this Sunday. Yes, day after tomorrow it will start, and currently it is priced at $599 for PCM and CS biology or CS subjects. So what all you get in this test series? So there will be 4-part test series. So part test series will start from this Sunday, and 4-part means there will be certain chapters. We will mention that what chapters will be there for upcoming week. So that part test will be there. After 4th part test is completed, there will be 8 full syllabus question. Okay, full syllabus tests. Other than that, what you will get? You will get PCM and biology or CS. So as I said, you will get all your science subjects covered. Next, you will get exam focused question paper. So you, if you write this question paper, you are more than ready for exams. Next, you will get all the questions, video solutions. We will provide you video solutions for all the questions again, and whatever doubts you might have regarding the questions that was asked in the test paper, that will also be clarified through this session. So if you are still waiting, do not wait. Currently it is priced at $599, 50% off. The price may go up anytime soon, so don't wait. Purchase it before 15th of December, because 15th of December is the first test. Now next, start with the blueprint for this chapter. So as you can see, all 3 blueprints are showing 7 marks from this chapter. So it is a medium important chapter, not super high important, not super less important, right? So this is a medium weighted chapter. MCQ from this chapter is 1. Is definitely going to come. According to all 3 blueprints, if you see, there is definitely going to be 1 MCQ from this chapter. Maybe slightly hard, maybe slightly easy, that we cannot predict. Now fill in the blanks also, as you can see, there will be definitely a fill in the blanks from this chapter. Okay, previously if you see other blueprints, there are some cases where there is in some blueprint there was one fill in the blanks, other blueprints there was no fill in the blanks, but from this chapter you are definitely going to get one blueprint, one fill in the blanks. Now short answer type and 3 marks question. Okay, 2 marks and 3 marks. Only one blueprint is giving you 2 marks and 3 marks question. Other than that, other 2 blueprints are giving you a 5-mark question. Now if you see here in the 5-mark question, instead of writing R, U, R for remembering, U for understanding, A for application, I hope you know, H for HOTS. So here they have mentioned ST. What is the meaning of ST? ST means split type question. Okay, so even though there are no 2 marks and 3 marks question in these two blueprints, this is a split type question. Split type question means the question will not be a straightforward derivative asking you, okay, derive lens maker formula, 5 marks. No, that type of question is not going to come from this chapter. So what type of question will come? State Huygens principle, using Huygens principle prove certain law. Or they will give you 3, 4, 1 2 marks question, 1 3 marks question, like that, or 1 mark 1 mark 3 mark, like that. So this will be split type question. So there will be no single 5 marks question. It will be split into multiple questions. So even if you are studying 2 marks and 3 marks, be careful, because 2 marks and 3 marks might be a part of the split type 5 mark question. So you have to study all the questions that I am going to discuss in today's lecture. So all the questions are important. You cannot say, okay, I only study 5 mark question, I am not interested for 2 marks 3 marks question. Not going to happen, because in the 5 mark question these 2 3 marks question might come. Similarly, for this 5 mark question they might ask one part of the 5 mark question in a 3 mark question, right? So let's start with all the questions that you are going to get today. So as you can see, you will be getting 15 usual MCQs, you will be getting 5 fill in the blanks, you will be getting 5 2 marks question, you will be getting 1 3 mark question. As I said, these 2 you can consider to be a single part, okay, because whatever 2 mark question 3 mark question you are getting, similar 3 marks question might come in 5 mark question as well. So I have not kept any separate 3 marks question only, I have clubbed them in 5 mark question as well. So total 30 questions I am going to discuss in today's lecture. Now let's start with the MCQ. A beam of unpolarized light of intensity I0 is passed through a pair of Polaroids. So a pair of, not a single but a pair of Polaroids with their pass axis inclined at an angle of theta. The intensity of the emergent light is equal to. So what is the question? This type of question is very common in cassette also. Cassette, they don't give you 2 Polaroids, they give you 3 Polaroids, sometimes 4 Polaroids, like that. Okay, but this is a reduced version of cassette. So you can say, because this is a board exam, so it is a reduced version of the cassette. So first they have said our unpolarized light. Unpolarized light means light like this, okay, is passing through a first Polaroid. Okay, so this is Polaroid 1 and this is the second Polaroid, Polaroid 2. The pass axis is making an angle of theta with respect to the first Polaroid, right? So they are making an angle theta with respect to each other. Now when suppose the intensity of this light is I, okay, what they have given, I0, right? It is given. So when it passes through the first Polaroid, its intensity becomes I by 2, I0 by 2. Okay, so this is the first Polaroid. Second Polaroid, now we can apply Malus law. From Malus law we know that whatever intensity is entering, okay, then we can add cos square theta to that. So this is the final intensity. So it is not I0 cos square theta, it is I0 by 2 cos square theta. Be careful while answering such questions. This is a tricky question. Whenever an unpolarized light passing through a single Polaroid, its intensity decreases to half. Okay, that part you have to remember. So first step is half, next step is Malus law, that is you have to apply cos square theta to the input intensity, so you get the final output, right? Now next is to observe sustained interference pattern on a screen placed at a suitable distance. In Young's double slit experiment, which of the following conditions are necessary? So Young's double slit experiment, they have specifically mentioned that this is for Young's double slit experiment and you want sustained interference. Sustained interference means when once you obtain the pattern, that will stay on the screen for longer time. Okay, it will not destroy after some time. You observed it for 2 seconds and after that it destroys. That is not a sustained interference. Sustained interference means it will stay there for some time, okay, even some hour also. So what is that? first whatever the conditions they have given, sources of light should be coherent. Obviously this is a necessary condition. Sources of light should be coherent always. Incoherent light does not produce interference. That's why when we lit up two different torches, we do not see any interference, because interference has to be produced by two coherent sources. If they are not coherent, you will not observe any interference. Next is sources of light should be narrow. Yes, sources of light should be narrow, so that you are getting specific light and the interference pattern is clear and crystal clear, right? Sources of light should be very close. This is also very important. These three conditions, all three conditions are actually necessary condition to observe Young's double slit interference. So you can say all A, B and C is the answer. Okay, sources should be close because that will give you a fixed bandwidth, fringe width, right? So fringe width will be fixed and that will be stable. So that's why all three conditions are necessary to observe sustained interference. But to observe interference, the only important part is part A. If they ask you what is the necessary condition to observe interference, obviously they should be coherent. But for Young's double slit experiment, sustained interference, coherent, narrow and they should be close together. These are all three important. Okay, so you have to understand the level of the question. Next question. Diffraction effect is exhibited by, so who all exhibit diffraction? Okay, only sound, only light, only matter, all types of wave. So diffraction is a property of wave. All types of wave shows diffraction. This is a very important question, very interesting question, and this question is directly lifted from your NCERT, and I have not prepared this question. I have taken this question from one of your model question paper. So directly they are asking questions directly from NCERT book, right? So if you read your NCERT book at least once, then you should be able to answer that. But you have to go read it carefully, right? You might miss this line. So all types of waves, including light, sound and matter waves, all waves shows diffraction. Diffraction is not property of light only. All types of wave actually shows diffraction. Now, if unpolarized light of intensity I0 is passed through a Polaroid, the intensity of the emergent light is. So here only one Polaroid is there and unpolarized light of intensity I0 is being passed. Okay, after emerging, okay, the intensity will be, what will be the intensity? I0 by 2, right? So it will be I0 by 2. So once unpolarized light, when becomes polarized, their intensity becomes half. Now if you add more polarized based on their relative angles, it will be cos square theta of that angle, right? That is Malus law. Next, the phenomena of bending of light at the corners of an obstacle is called. So the phenomena of bending of light at the corners of an obstacle is called diffraction. This is the definition of diffraction. Okay. According to Huygens principle, the speed of the secondary wavelets is, this is from your 2024 question paper. So according to Huygens principle, speed of the secondary wavelets same as that of the wave. Okay, secondary wavelets also travel with the same speed as the original wave. Okay, so they don't have any different speed. All the wavelets, secondary wavelets, they all travel in the same speed. By the way, wavelets means children of wave. Okay, so when you consider primary wavefront, this is called primary wavefront. So all the lights are traveling here at the same time. This is called primary wavefront. Now Huygens principle states that any point on this secondary primary wavefront are the sources of secondary wavelets. Secondary wavelets means you can consider them to be a sources of light as well, individual sources of lights. Now these are the secondary wavelets. They also travel with the same speed. These secondary wavelets, they also travel with the same speed, obviously, right? And after some time, if you consider a common tangent, you get the primary wavefront, secondary wavefront, like that. Next, when a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wavefront is. So very, very interesting. Okay, you have, this is a convex lens. You might think, oh sir, this is wave optics chapter, not light chapter. But yes, wave optics also has some convex lens, if you remember. So when a point source light is placed at the principal focus of a thin convex lens. Okay, point source, let us understand what is this. So point source is placed at the focus. So after emerging, it will become parallel, right? So initial wavefronts are spherical. This is because if the source is point, then you will get a spherical wavefront. Now parallel light means the wavefront will be parallel as well. So plane wavefront. Okay, plane wavefront will be the answer. Now if in your book they have not given this thing, they have given the opposite. So in your book they have given a plane wavefront incident on a convex lens. After that they becomes convergent, so they become convergent like this. So that is the wavefront when you are considering from a convex lens, parallel rays are falling. So in that case what happens is, after reflection the wavefront becomes spherical. Okay. Now the shape of the wavefront for light coming from a distant star. So if the star is very distant, then definitely we observe parallel source of light. As we know, distant star can be considered an object at infinity. If the object is at infinity, then the rays are parallel. Parallel rays means the wavefront are plane. Okay, again plane wavefront. Okay, so in this case also plane wavefront, but you have to understand, if the rays are parallel, the wavefronts are plane. If the rays are converging at some point or diverging from some point, they are basically spherical wavefront. Okay. Next, the principle of superposition of waves applies whenever one source of light falls on a screen, one source of light moves across a screen, two or more sources of light illuminate the same point, two or more sources of light illuminate two different points. So principle of superposition is applicable when two or more sources illuminate same point. Okay, so principle of superposition means when two waves are falling at the same point, whatever the intensity, whatever the amplitude of the resultant wave, so basically they have to illuminate the same point, then only you can apply the principle of superposition. Okay, we will have constructive interference if the path difference is delta x equals to n lambda, delta x equals to n plus 1 lambda by 2, delta x equals to n plus half lambda, delta x equals to n minus half lambda. Okay, so we observe interference only when it is directly proportional to n lambda. So n lambda is the correct answer. Okay, these are all destructive interference. So only constructive interference is when delta x equals to n lambda, n is given plus minus 1, plus minus 2, plus minus 3, like that. Okay. To observe diffraction, the size of the obstacle should be lambda by 2, where lambda is the wavelength, should be of the order of the wavelength, has no relation with the wavelength, should be much larger than the wavelength. So be careful. So to observe diffraction, the size of the obstacle should be of the order of the wavelength. Okay, should be of the order of the wavelength. Next, two lights of each intensity I0 are used in Young's double slit experiment. The intensity of the interference maxima is, so the intensity of the interference maxima is 4I0. Okay, so you have to be careful, it is not 2I0. For maximum position the intensity becomes 4I0, for minima the intensity becomes 0. Okay, so for maxima it is 4I0, for minima it is 0. When a compact disc CD, okay, I hope everyone has seen these things. Nowadays these are very, very less common. When a compact disc CD is illuminated by small source of white light, the colored bands that are observed is due to diffraction. Okay, so when you illuminate a CD using a normal white light, okay, you see colored bands on the CD. That is because of the diffraction. Different lights bends by different amount, that's why you see colored bands. Okay, while both light and sound show wave character, diffraction is much harder to observe in light. This is because speed of light is greater, light does not require a medium, wavelength of light is far smaller, waves of light are transverse. So it is nothing to do with speed or nature of the wave, it is because light wavelengths are much smaller, so you need much thinner obstacle to observe diffraction. Okay, to observe diffraction in sound, sound's wavelength is much higher, so even normal objects can show diffraction for sound, right? But in case of light, to observe diffraction, what you need is you need a very smaller edge. Okay, so where light can bend, it should be on the order of the wavelength of the light, right? So that's why this is difficult to observe in case of light. Now, which of the statements are correct with reference to a single slit diffraction? Fringes are of unequal width, fringes are of equal width, light intensity is not conserved, intensities of all bright fringes are equal. Okay, so fringes are of unequal width, that is the only correct statement with respect to diffraction by a single slit. Okay, we know that in single slit diffraction what happens, the central maxima is very bright and very broad, whereas other fringes are very small and slowly decreasing. Okay, so single slit diffraction shows a very bright starting middle patch, that is called the principal maximum. Okay, and all other maximas are very less bright and they slowly die out. Now let's look into the fill in the blanks now. A wavefront is a surface of constant dash. So let's see what are the options. Constant wavefront is a surface of constant transverse wave particle maximum phase. So as you know that wavefront is a locus of constant phase or surface of constant phase. So you have to careful and answer this as phase. The light waves are dash in nature. So in our previous MCQ also we have seen what is the nature of the light wave. So light waves are, if you see in the given option, first option, transverse in nature. So light waves are transverse in nature. The phenomena of bending of light around the edges of an obstacle is called. So this one also we have answered. The phenomena of bending of light in a sharp obstacle is called diffraction. Okay, so this is called diffraction. This one is also done. Next, if two waves are coming from two coherent sources superposed at a point in phase, then the intensity of the light at that point, so when two waves interfere at same phase, the intensity will be maximum. Intensity will be maximum. Okay, phenomena of polarization proves that proves the dash nature of light waves. So polarization is only possible for a wave, so it proves the wave nature of light. Okay, diffraction, interference, that is possible for other types of wave as well, but polarization is only possible for a natural wave. So that's how you can say, okay, this is the this is only a wave, light is a pure wave. Okay, so this is only possible for waves. So polarization is a very important property and it is only seen for electromagnetic waves only. Now let's move on to the next part, 2 marks question. Now 2 marks question, this question particularly, this is a very important question. This is a 5-star question. Okay, 5-star, I am writing 5-star question. Why 5-star question? This question is most asked question from this chapter. This question can be asked as a 2-mark question. This question can be asked as a 3 marks question. This question can be a part of a 5 marks question as well. Okay, so this question is very very important, super important question. What is this question? Mention 2-3 uses application. Sometimes they will say uses, sometimes they will use applications. These are same things, okay? So don't get scared. In this question, if I have only mentioned uses, then in the exam they will say applications, and you will say sir only taught us uses, sir has not taught us applications. So what we will do? We will leave the question. No, they are same thing. So uses and applications are same thing, okay, of Polaroids. So mention 2 or 3 uses of applications of Polaroids, and you only need to remember 3. You don't need to remember more than 3. So what are these 3 points? Polaroids are used to control the intensity in sunglasses, window panes, etc. Now I have joined 2 different uses in a single point. You can mention them in a single bullets as well, separate bullets as well. What are the first property? First of all, it is very important to control intensity in case of sunglasses and window panes. Window panes means when if you have seen the windows where light directly not coming inside the room, okay, it appears suddenly, even though the window pane is completely transparent, completely white, the light that is coming inside is not super bright, it is reduced because the window panes are polarized, and that's how you can control the temperature inside a room. Okay, in big companies, big MNCs, okay, they use this kind of material in their buildings so that the room inside remains cool and they can save on electricity. That is called the light. Right now they are called greener initiatives. Okay, now Polaroids are also used in photographic cameras and 3D movie cameras. So in the sensors of cameras, okay, so if you are taking a picture in using your mobile camera or a expensive camera, okay, or some movie cameras, IMAX cameras, I hope you know IMAX cameras, they use polarizers, okay, inside Polaroids, inside their cameras. Also 3D cameras is, I hope everyone has seen 3D movies, right? So 3D movies are shot on 3D cameras. Some are digitally converted into 3D, okay, the quality of those 3Ds are not good. Some movies like famous movie Avatar and Avatar 2, they are shot in 3D cameras itself, right? That's why their 3D quality is very, very good, right? So if a movie is shot on a 3D camera, their quality, their picturization are awesome. But if you convert a movie into 3D, their quality is not super good, okay, even though they are sometimes okay, but they are not super good. All the expensive movies, Hollywood movies, especially if you are a Hollywood movie fan, then most of the Hollywood movies, if they are coming in a 3D format, most of them are shot in 3D camera, okay. Even if you can see in their posters, it mentioned shot in IMAX 3D, okay, shot in IMAX is a special kind of camera. If you are watching in IMAX theater and it is shot in IMAX, then you can enjoy the movie the best, okay. But if it is not shot in IMAX, but if you are watching in IMAX, then you may not get the same feel, okay. They have some technical specifications. Similarly, when you watch a 3D movie, you require a special kind of glasses, okay. So those glasses, if you see them, okay, when I was a kid, they used to give us red and blue glasses. If you wear that, you will see 3D. Those are very old format, okay. Those are also not super good, red and blue. But right now what they do, they are giving you Polaroids as 3D cameras, okay. So 3D cameras are based on those Polaroids. They are also super good, so they are also used in 3D movie glasses. So Polaroids are used in recording 3D movies, Polaroids are used in watching 3D movies. Interesting, isn't it? Okay, so I hope you remember these 2 points. These 2 points are very simple to remember. So 3D cameras as well as 3D glasses. So everything is based on Polaroids. So if there are no Polaroids, you would may not be having such a fun in a next 3D movie that you are going to watch, right? So if you have watched any 3D movies, don't forget to mention that in the comment. Next, question number 22. Give the conditions for constructive and destructive interference of light in terms of path difference. So what is the condition for constructive interference? Constructive interference we already have learned in our MCQ section, that delta x equals to n lambda is the constructive interference. Destructive also you have learned in the same question as a wrong option. So destructive interference is given by n plus half lambda. Okay, so n lambda is for constructive. If you see somehow n is an integer value, okay, obviously n is an integer value, and if the path difference is integral multiple, basically they say like that, if the path difference is integral multiple of lambda, then it is a constructive interference. And if you put any values of this value, then you will get an odd multiple of lambda by 2. If the path difference is an odd multiple of lambda by 2, you will get destructive interference. What about even multiples? Even multiples you can consider that will be a integer multiple of lambda. So even multiples are included here. Odd multiples of lambda by 2, they are here. Sometimes some books they write it like this: 2n plus 1 lambda by 2. This is also correct. Okay, if you see this form is also correct. This form is given in a book, so I am using this form. Otherwise, some books, some other competitive exam books, they use this notation. This is also fine. So don't worry if they say, sir, I know 2n plus 1 lambda by 2, that is also fine. If you are writing n plus half lambda, that is also fine. Anything is fine, but you have to mention the values of n. Next question. What are coherent sources of light? Give one example. So coherent sources of light are light sources that emit light waves with the same frequency, wavelength and phase, or have a constant phase difference. Okay, so first of all they will have same frequency, same wavelength and constant phase relation. Okay, so constant phase relation means, as you are suppose you and your brother, okay, suppose A and B, two twins, okay, two twins are there. Okay, so two twins, they are born, say this born after 5 minutes, one born after 5 minutes of the another. Okay, so they are identical twins, they look exactly like another person, and as they are growing up, this person is always growing, is 5 minutes ahead of the second person. They look exactly same, their height is exactly same, they are everything same, except this person is 5 minutes earlier than the other person. So whenever he will say, "Arey, I am 5 minutes older than you," right? So so they are saying they can be considered as coherent humans. If lights which are not alive, if you can produce lights such a way that they always have this kind of relationship, they look exactly same, they behave exactly same, only thing is one light is slightly ahead in time than the other, then we say they have a constant phase difference. If the phase difference is changing with time, then the phase difference is not constant. Okay, so phase difference is not constant if the phase is changing, right? Now, what is the diffraction of light? So diffraction is the bending or spreading of light spreading of light waves. They have mentioned light, so spreading of light waves around obstacles or through openings. It is most noticeable when the obstacle or wavelength is similar in size to the wavelength of the wave. So as the light is traveling through a say this is an obstacle and light is traveling, okay, by default normally you should see some light only here, that is a rectilinear propagation of light, right? But some part of the light will bend and you will see some light in the dark zone as well. This should be the optically dark zone because light is traveling only in the forward direction, right? But because of this bending, this is called diffracted ray. This is called diffracted ray, and this process is called diffraction. Okay, so diffraction is basically bending of light in a sharp object, sharp corner. Okay, that is the diffraction. Normally light should travel in a straight path obviously, but some lights travel other than the straight path, and that's why it is called diffraction. Next, write the formula for Malus law. Very easy question. This question came once in your previous year, that's why I have included. So what is the formula for Malus law? Malus law says the intensity coming out, you have to mention the statement also, the intensity of the light coming out of a Polaroid plane polarized light, cos square theta. Okay, so what is this? I naught. So remember that Malus law states is applicable for plane polarized light only. It is not applicable for unpolarized light. Intensity of plane polarized light. Okay, theta is the angle between the plane of polarization and the axis of the Polaroid. Okay, so suppose this is a plane polarized light. Plane polarized lights are generally denoted like this. Okay, this is the plane polarized light. Now this is the axis. These arrows represents the axis of the polarization, right? So this is the only light waves present in this light. That's why these are called polarized light. And if you keep a Polaroid in the path such that that Polaroid is making an angle theta with the path axis of this, then after it comes out, okay, the intensity decreases, the polarization angle changes. Now this intensity is say I, and this intensity is I, and this initial intensity is I naught. If this angle is theta, then the emergent intensity is given by Malus law, right? This is the formula for Malus law. Next question, using Huygens principle, show that the angle of reflection is equal to the angle of incidence when a plane wavefront is deflected by a plane surface. This is a 3-mark question. This can be asked as a part of a 5-mark question, or this question can be asked standalone as a 3-mark question. So first you have to do, what you have to do, you have to draw the diagram. So there is a plane mirror, right? Light ray is traveling. So now in this case, instead of using one single light, you have to draw 2 parallel light. Okay, 2 parallel beam of light. You can use your scale, slant it, draw like that. That is also fine. So now suppose this is say AB, this is say CD. Okay, now if you draw a perpendicular from B to CD, so that this angle is 90 degree. Okay, say BE. Then this line represents a incident wavefront. Why so? Because when the light is reaching B, the same time the light from the source reaching E. These two are brothers. These two have a phase relationship. These two are twin brothers, okay, and they are reaching here at the same time. Now when the light is reached here, okay, and the light is forward traveling forward direction, okay, in the meantime the light from B, it will start reflecting. It will start reflecting and it will go in a different direction. Okay, so it is the reflected ray, right? By the time the light is reaching from E to D, the light from reflected ray reaching say another direction, another point, okay, from say B to C, D, E, F, B to F. Now if you draw a perpendicular from this line to this line, okay, such that this is also perpendicular, okay, then this is called, DF is called the reflected wavefront. Okay, DF is the reflected wavefront. Okay, so let me write down all the details. First you have to draw this diagram, then you have to mention how you draw this diagram. So DE equals to incident wavefront. Incident wavefront. Everything will be done in terms of wavefront only, and DF is the reflected wavefront. Okay, so this is the main thing, and incident wavefront making an angle I and reflected wavefront making an angle R. So we are trying to prove the law of reflection. So what is the law of reflection? Law of reflection states that I is equals to R. So that is our main target, to prove that I equals to R. How can we do that? So first we will consider the triangle. First of all, let us say that the speed of light, let speed of light in the medium is V. Okay, speed of light in the medium is V. Then and the time taken by the light to reach from E to D is T. Okay, so light is taking a time T to reach from here to here. So what is the, and its speed is V. Speed is V in this medium, and the time taken by light from reaching from E to D is T. So what is the distance DE? So distance DE is basically speed into time. S equals to VT, right? Here this is the S. Okay, V is the speed of light, T is the time taken. So this is the DE equals to VT. Now in the same time, whatever time light is taking from reaching to E to D, in the same time light is reaching from B to F, right? So the time taken to reach from B to F is also T. Similarly, BF is also equals to VT. So what we can say that, therefore DE equals to BF. Okay, because both of them are in the same medium, so we have established that BE and DF, they are equal, right? Now let's consider the triangle. Consider triangles BFD and triangle BED or BDE. Okay, so these two triangles we are considering. Now if you see in this triangle, both triangles have BD common, okay, and BF equals to D. So first let us write BF equals to DE, sorry, BF equals to DE, yes, and angle BFD equals to angle BED. Why? Because both of them are 90 degree. If it is a wavefront, the wavefront will always intersect the light at 90 degrees, right? That is the property of wavefront. Wavefronts are always perpendicular because it is, if you draw a tangent, the tangent represents the direction, right? So this is the wavefront. So they are always 90 degrees, and BD is common. BD is common, right? So what we can write, by side angle side, by side angle side, okay, these two triangles are congruent. BFD congruent BDE, right? So these two triangles are congruent. So if they are congruent, their angles, similar angles are equal. So we can say that EBD, therefore angle EBD equals to angle FDB, angle FDB, that is I equals to R. Okay, so this is the incident wavefront. So incident wavefront will make an angle I, and this is the reflected wavefront. Reflected wavefront will make an angle R. So I is equals to R. This is hence proved. So you have to write hence proved, right? Laws of reflection is now proved. Okay, so I hope this is clear. This is the first step. This is the description you have to write. This diagram is compulsory, okay, and this description is definitely compulsory. Okay, I will provide this PDF, download it, study from here. This is the shortest possible explanation that you might find in all over internet. Next, now let's look into the 5 marks question. Two coherent waves of constant phase difference undergo interference. Obtain the expression for the resultant displacement. This question directly taken from your model question paper. So let y1 is equal to a sin omega t, and y2 equals to a sin omega t plus phi interfere. Okay, two coherent light of constant phase difference. So phase difference, this is the phase difference. Okay, phi is phase difference, this is constant. Okay, A is amplitude, this is also constant, right? So now they superimpose, they interfere. If they interfere, then what is the resultant intensity? The resultant intensity is given by y1 plus y2. What is that? Y1 will be a sin omega t plus a sin omega t plus phi, right? Now take a common, so you will get sin omega t plus sin omega t plus phi. Okay, now let's add them. A, what is sin A plus sin B? So sin A plus sin B is 2 sin A plus B by 2 times cos A minus B by 2, right? So what is the sum? So let me write it here slightly. I have to erase this because I don't have any extra pages. Next, so this will be A times 2A, so 2 can come out, so sin omega t plus phi, so 2 omega t plus phi by 2 times cos omega t cancels minus phi by 2, right? So what is this? So this can be written as 2a. Let me write it in the first. Cos minus theta is cos theta. So cos of phi by 2, and let me divide it. You will get sine omega t plus phi by 2. So this is the expression for the resultant wave. Okay, so this is the expression for the resultant wave. So the resultant wave, you can write them as y equals to 2a cos phi by 2 sine omega t plus phi by 2. Okay, so this is the resultant waveform. From here you can calculate the intensity. Intensity is basically, now this is the new amplitude. This is also constant, right? Phi is constant, so this is the new amplitude. This is, you can, if you represent this by r, then you can even calculate the resultant intensity. So resultant intensity is basically new intensity is r square, so this will be 2a square. So from there you can prove whatever the intensity relationship as well. So but in this question they have not asked about intensity, so we will leave it here. Okay, if you are interested to know about intensity, this is part A. You can mention that in the comment below. I will make a short video on that. Now write the conditions for constructive and destructive interference in terms of phase difference. So conditions for path difference, if you remember, delta x was n lambda, right? This was the path difference for constructive. Right, so this was the condition for constructive interference in terms of path difference. For phase difference, delta phi, this same condition you can multiply it with 2 pi by lambda. Okay, so in terms of phase difference, if the phase difference is multiple of 2n pi, then it is a constructive interference. If the phase difference is 2n pi, then it's a constructive interference. And in terms of destructive interference, if the phase difference is n plus half times lambda times, this is the path difference delta x. So basically what we are doing, we are converting the delta x into delta phi. So to convert it, always you have to multiply 2 pi by lambda. So lambda cancels, you get n plus half times 2 pi. Okay, so this is the condition for destructive interference. You can write them as an individual, or you can show the calculation, whatever you like. So for constructive interference, the phase difference should be 2n pi. For destructive interference, the phase difference should be n plus half into 2 pi. Okay. Now next question, what is a wavefront? Okay, wavefront definition, we have learned that this is the surface of equal phase, constant phase, surface of constant phase, or locus in terms of mathematics, locus of constant phase is called the wavefront. Okay, explore the relationship between parallel plane wavefront through a thin prism with a neat diagram. So that diagram is given in your book. So suppose this is a prism, parallel rays are falling on it. So parallel rays are falling on it. So this is the parallel ray. After refraction, it will be like this. The ray bends towards the base. Okay, we know that when the ray passes through a prism, the ray bends towards the base. So this is the diagram, simple diagram you have to draw. It's not a complicated diagram, not a difficult diagram, only this simple diagram you have to draw. If you can show the path through that is fine. If you don't show, that is also fine. Yeah, how can you show it? If you are drawing this, if you want to show, now I want to show the diagram. Okay, so in that case, what you have to do, you have to draw it like this. Be careful, keep them parallel only, and then you draw, this is the reflected, this is the incident, wavefront, this is the refracted or emergent wavefront. Okay, now give any two differences between constructive and destructive interference of light. So you have to write constructive and then you have to write destructive. So this is a very easy, simple difference. First is in case of constructive interference, intensity increases, intensity decreases. Okay, next is condition is delta x equals to n lambda. Condition is delta x equals to n plus half lambda by 2, right? So this is the simple answer. You can write any other points that you might know, mention in the comment below. If you know any other points other than these two, you can mention that. Okay, next question. State Huygens principle. Using Huygens principle, arrive at the Snell's law of refraction for a plane wave. This is slightly complicated, not super simple. So let's see what we can do about it. First, we will do Huygens principle. Huygens principle states that secondary wavelets travel with the same speed. Okay, each point on a primary wavefront is a source of secondary wavelets. So each point in a primary wavefront are the sources of secondary wavelets. Okay, so this is the principle of Huygens principle. You can mention a secondary wavelets travel with the same speed as the primary wave. That is also fine. Now, next is using Huygens principle, arrive at the Snell's law. So basically, Snell's law means you have to do the refraction part. Okay, that is slightly difficult. This question has come in the previous year, so you cannot ignore that. Okay, so suppose this is the incident ray. Again, the incident light is reaching here. So this part is same. A, B, C, D, E. This is same. This up to this part, everything is same as reflection. After that, so basically, what is the meaning of that? When the light reaches here, the light from this source reaches here, up to here. So they are at the same phase. So this is the incident wavefront. This is the incident wavefront, making an angle I. Now by the time light reaches from here to here, okay, this light has already entered in the second medium and it starts refracting. Okay, so it reaches, suppose after, by the time the light reaches here, this light after bending in the normal, from the normal, it reaches to this point. Okay, now if you join this point and this point, then this will give you the refracted wavefront, this angle will be refraction, angle of refraction, say R. Okay, and you have to prove the Snell's law, right? Now again this angle is 90 degrees, this angle is 90 degrees obviously. Okay, and now there is no congruency, you cannot directly prove any congruency because these two sides are not same. Suppose the speed of light in this medium is v, speed of v1, say speed of light in this medium is v2. There are two mediums, medium 1, medium 2, light is traveling from medium 1 to medium 2, speed of light in this medium is v1, speed of light in this medium is v2. Now same as reflection, now tell me what is this distance. Suppose the time taken by the light from reaching from here to here is t, the same time is taken by light from reaching here to here, that's why this is the reflected wavefront, right? So what is the distance ED? So distance ED or distance DE is basically V1t, right? So distance DE is V1t, or what is the distance EF? This point is F, right? What is the distance BF? Distance BF is V2t, right? So this is clear. Now in this case V1 is definitely not equals to V2. If it was so, then their light will only pass through, there would be no refraction, right? Now what we will do, we will use the fact that these are right angle triangles and we will try to find the angle sine theta, sine I basically. So from this triangle, what is the value of sine I? From this triangle, what is the value of sine I? Sine I is the some people have curly brown hair turned permanently black. If you remember this, it will help you to remember sine is perpendicular by hypotenuse. So if this is the angle, this is the perpendicular. Okay, anything opposite to the angle is perpendicular, right? So this is the perpendicular by hypotenuse. Hypotenuse is opposite angle to the 90 degrees. So this is the hypotenuse. So DE by BD, right? DE by BD. Now let's see what is DE is. DE is nothing but V1t by BD, right? Or what we will do, we will try to find the value of, from this, you have to remember this is a trick, or you can do, okay, let's not do the trick. I will solve in a simpler way. Now next part is we will find the angle sine of R. Why we are doing sine of R, sine of I? Because Snell's law is related with sine thetas, right? Sine I, n1 sine I is equal to n2 sine R, right? That's what we are trying to prove. That's why we are trying to find the sine angle first. Now this is the angle, means what is the perpendicular? Perpendicular is the opposite side. So BF, so BF by again BD, right? BF by BD, same, this is 90 degree angle, so that means the opposite side will be the hypotenuse, right? So it will be V2t by BD, right? Now what we will do, we will divide them, sine I by sine R, that is equals to V1t by BD divided by V2t by BD. So BD both were in device, so they will cancel. Okay, T will cancel, so you get V1 by V2. Okay, or what we will do, now we will do the cross multiplication. Okay, so cross multiplication, we will get 1 by V1. Why I am writing like that? We are trying to bring everything related to this side in one side and everything related to this side, second medium, in the other side, right? So sine R is here and V2 is also here. V1 is on the upper side and sine angle I is also in the upper side. So we have taken everything related to upper side on our left hand side and everything related to downside is on our right hand side. Now what we will do, we will multiply both sides with C. Okay, C by V1 sine I equals to C by V2 sin R. So what is C by V? C by V1 is the refractive index of medium 1. That is the definition of refractive index, right? So definition of refractive index is that speed of light in vacuum divided by speed of light in that medium gives the refractive index. So N1 sin I equals to N2 sin R. So you can write N1 is equal to C by V1, N2 equals to C by V2 by definition. Right? So this is the Snell's law. This is the derivation part. You have to add few words to describe this diagram and why we are writing it like this. Okay, so incident wavefront, reflected wavefront, by the time light reaching from E to D, the refracted light reaching from B to F. So small sulfur description of this image is required. Okay, and after that this derivation is very straightforward. If you remember, see, I did this frankly I did this derivation for a very long time ago, okay, and I have not even prepared for this lecture. I did only from understanding. If you have understood this concept, you can do it on your own as well. Okay, for this lecture I came completely unprepared. I just knew, okay, if I can draw this diagram I will be able to answer this mathematics, right? So this is just a geometry. Everything, even reflection and refraction, everything is geometry. No such physics is there. Only physics is there is that V1T and this drawing this incident and reflected wavefronts. That's it. And you have to have the knowledge that if this is a wavefront, then this angle is 90 degree. If this is the wavefront, this angle is 90 degree. Right? So just try to understand it rather than mugging it up completely. You cannot mug this. This is impossible to mug. You cannot remember all this derivation, but if you understand it, you can even teach it to your grandkids. Right? Now, last question. What is interference of light? So interference of light is when lights of two coherent light superpose at a point, okay, their intensity decreases or increases based on the phase difference. That is called interference of light. So definition you can take it from your book. I have given it. If you want, you can write it down. Give the conditions for constructive and destructive interference of light in terms of path difference. So this question is already answered, okay, in the 2 marks question. So this question I have only keep so that to make you understand how the questions that we have discussed in 2 marks, 3 marks question can be asked as a 3 marks question, as a 5 mark question. Okay, so this question we have already asked in short answer type 2 mark question. Okay, mention any 2 applications of Polaroids. This question is also asked in short answer type 2 marks question. First question is this question, so that's why I said this is a 5-star question. Okay, all the questions can be asked as a 5-mark question as well for this chapter particularly, because the 5-mark questions are short split type questions. So if you see, all the questions that we have solved from this chapter are split type. It was historically so and it is currently as well. Okay, so whatever question will come from this chapter, that will be split type question. So there will be a small 1-mark question. For example, this question is 1 mark, this question is 2 mark, this question is 2 mark. Okay, so you have to understand and answer them properly. Okay, so these questions you can find in our short answer type questions. I am not going to explain it any more right now. If you are currently studying in 2nd PU and if you are wondering that what to do after your if you are wondering that how can I be successful in your PU2 final exam, then we are presenting you PU2 success blueprint test series, very important, okay, for you, and it is going to be starting from coming Sunday, that is 15th of December. Okay, and currently it's priced only at $5.99, less than price of a pizza. Okay, and what you will get in this series, you will get 12 mock tests. Out of the 12 mock tests, 5 part tests part tests are designed such that your entire syllabus is covered. Okay, 4 part tests. In 4 part tests you will get physics, you will get chemistry, you will get biology. So this 4 part test includes all the subjects. Okay, total all the subjects, physics, chemistry, maths, biology, everything is covered in this 4th part. Okay, then 8 full syllabus questions. In the 8 full syllabus questions you will be getting 2 physics, 2 chemistry, 2 bio, okay, 2 maths or 2 CS. Okay, so CS is also there, so you don't worry, 8 full syllabus you will get everything. Next, subjects covered are PCM and then biology or CS. Okay, exam focused question papers with solutions. We will give you the PDF solutions, and if you are not satisfied with PDF solutions, we will be here to give you complete video solutions with proper explanation of all the questions, right? And any doubts that you might have from the question paper, that will also be cleared on the go. So don't wait, purchase this. This is only available at $5.99. It's a limited time price, so don't wait for the price to grow up. Buy it right now. Now if you like this video, don't forget to give it a thumbs up and share it with your friends. I'll be back with a new PU2 Brahmastra series on Tuesday. Till then, bye.